Welcome back to another video. In this video, we will go over an example to help you become comfortable interpreting the regression output produced in Python for simple linear regression. Let's go over an example together. A chemist is producing oxygen through a complex chemical process. Based on 20 experimental runs that have already been conducted, the chemist knows that the purity of the oxygen produced depends on the level of hydrocarbon present in the raw material. Using these prior observations, the chemist applies Python to fit a simple linear regression model that estimates the oxygen purity before running a new experiment, given a known hydrocarbon level in the raw material using least squares method. Using the partial output provided, answer the following question. 1. Report the fitted regression lines shown in the table. Interpret the slope and the intercept. Please pause the video here and take a moment to answer question 1. From the provided partial output, we can see the fitted regression coefficients and their corresponding standard errors. Using the coef column, we report that the fitted regression line is y equals 74.283 plus 14.947 times x, where y denotes oxygen purity and x denotes the hydrocarbon level. In this fitted simple linear regression model, the intercept, beta 0, is 74.283. This represents the expected oxygen purity when the hydrocarbon level is 0. But, because the observed hydrocarbon levels range from 0.99 to 1.55, the value, x, equals 0 is outside the range of the data. As a result, the intercept does not have a direct practical interpretation in this context. Formally, the intercept represents the expected oxygen purity when the hydrocarbon level is 0. However, since the chemist has no data near 0 hydrocarbon, this scenario is not observed and may not even be physically meaningful for the chemical process. Therefore, interpreting the intercept as an actual oxygen purity value should be done with caution. In practice, the intercept mainly serves a mathematical role, allowing the regression line to fit the data properly over the observed range of hydrocarbon levels. The slope is the more meaningful parameter here because it describes how oxygen purity changes within the range of hydrocarbon values actually studied. The slope, beta 1, is 14.947, which indicates that for each 1 unit increase in hydrocarbon level, the expected oxygen purity increases by approximately 14.947 units. In question 2, we are asked to define 95% confidence intervals for both the intercept and the slope. Please pause the video here and take a moment to answer question 2. To define the 95% confidence intervals, we need the estimated values of beta 0 and beta 1, their corresponding standard errors, and the critical t-value corresponding to 0.975 with 18 degrees of freedom. Lugging in these values, the 95% confidence interval for the intercept ranges from 70.966 to 77.631. This means that, based on the data and the assumptions of the linear regression model, we are 95% confident that the true value of the intercept lies within this range. The 95% confidence interval for the slope ranges from 12.181 to 17.714. This interval has a clear practical interpretation. It indicates that we are 95% confident that for each 1 unit increase in hydrocarbon level, the expected oxygen purity increases by between approximately 12 and 18 units. Question 3 is asking us to perform hypothesis tests for the intercept and slope and report whether the intercept and slope are significant at 0.05. Please pause the video here and take a moment to answer question 3. We can compute the t-test statistics for both the intercept and the slope directly from the reported regression output, using only the estimated coefficients and their corresponding standard errors. For beta 0, we subtract the hypothesized value of 0 from beta 0 hat and divide the result by its standard error. This gives the t-test statistic for the intercept, which is 46.617. Similarly, for beta 1, we subtract the hypothesized value of 0 from beta 1 hat and divide by its standard error, yielding the t-test statistic for the slope, which is 11.35. To draw conclusions from these hypothesis tests, we can use either the rejection region approach or the p-value approach. Using the rejection region approach, we note that the critical t-value for a two-sided hypothesis test in simple linear regression at a significance level of 0.05 is the negative and positive values of t of 0.975 with 18 degrees of freedom, which is approximately 2.1. Since both test statistics, 46.617 and 11.35, are much larger than this critical value, they fall in the rejection region. Therefore, we reject the null hypotheses and conclude that both the intercept and the slope are statistically significant. Now consider the p-values. Can we determine the p-values associated with these t-test statistics? The answer is yes. Once we know the t-statistics and the degrees of freedom, the p-values are fully determined. Because we are working with simple linear regression using 20 observations, the t-test statistics for both coefficients follow a t-distribution with 18 degrees of freedom under the null hypothesis. As discussed in our lecture on continuous distributions, the central t-distribution and the standard normal distribution behave very similarly as the degrees of freedom increase. Using the empirical rule, we can see that even the smaller t-statistic of 11.35 lies far out in the tails of the distribution, which corresponds to an extremely small p-value. For a two-sided test, the p-value is calculated as the probability of observing a t-value whose absolute value is at least as large as the observed statistic. Because the observed t-statistics for both the intercept and the slope are so large, the probability of observing such extreme values under the null hypothesis is extremely small. As a result, the corresponding p-values are very close to zero, providing strong evidence against the null hypotheses. To report the results of our hypothesis tests, we can rely on either the p-value approach or the rejection region approach and state our conclusion accordingly. For example, using the p-value approach, we note that because the observed t-statistics for both the intercept and the slope are extremely large, the probability of observing such extreme values under the null hypothesis is extremely small. As a result, the corresponding p-values are very close to zero, providing strong evidence against the null hypotheses. We therefore conclude that both the intercept and the slope are statistically significant. The next question asks us to report the ANOVA F statistic corresponding to this fitted regression line. Please pause the video here and take a moment to answer question 4. In simple linear regression, the ANOVA F statistic is equal to the square of the t-test statistic for the slope. Since we already calculated the t-statistic for the slope to be 11.35, the corresponding F statistic is the square of this value, which equals 128.87. In this question, we are asked to examine the QQ plot and the residuals plot and comment on the adequacy of the fitted simple linear regression model. Please pause the video here and take a moment to answer question 5. From the QQ plot, we observe that the points lie approximately along a straight line, with no strong systematic departures or pronounced curvature. This suggests that the normality assumption for the residuals is reasonably satisfied. Minor deviations at the tails are common in practice and do not appear to be severe in this case. From the residuals plot, we see that the residuals are randomly scattered around zero with no clear pattern, such as curvature, funnel shapes, or systematic trends. In addition, the spread of the residuals appears roughly constant across the range of fitted values. This indicates that the assumptions of linearity and constant variance are reasonable. Overall, these diagnostic plots suggest that the simple linear regression model is adequate for the data, and the model assumptions do not appear to be violated in any meaningful way. Thank you for watching. I hope this video was helpful, and I look forward to seeing you in the next one.